traveling thousands of years across stone and memory, and enters a dark chamber buried beneath the earth at Newgrange, Ireland. For 17 fleeting minutes, a beam of sunlight pierces the roof box, illuminating the ancient burial chamber with a brilliance that seems almost intentional, almost conspiratorial. It is a moment that occurs once a year, yet its significance stretches across millennia, a whisper from our ancestors that demands attention. This is no accident. For at Newgrange, for Stonehenge, for Chanquillo in Peru, for the vast sands of Nabta Playa, for the Inca terraces of Machu Picchu, and even along the monumental causeways of Giza, a single day, the winter solstice, has been etched into stone with astonishing precision. Unrelated cultures, separated by oceans and millennia, independently encoded the same celestial event, as if the sun itself were a common language binding humanity across time. One cannot help but wonder, why? Why does this single day hold such an enduring power over human imagination and engineering? The question is not merely poetic, it is mathematical, scientific, and astonishingly precise. In 2023, archaeoastronomers revisited many of these ancient sites using modern satellite mapping, horizon modeling, and 3D simulations. At Chanquillo, for example, the 13 towers, built in the 3rd century BCE, create a living solar calendar. Observers at fixed vantage points could track the sun's annual journey, from the summer solstice to the winter, noting its daily position over the horizon. At Stonehenge, the trilithons align along a corridor pointing to the sunrise of the summer solstice and the sunset of the winter solstice, verified repeatedly with geodetic surveys. Even in the New World, the Maya and the Inca engineered their temples and ceremonial platforms to capture shadow, light, and solar angles with breathtaking accuracy. It is as if each civilization, independently and without contact, had discovered the same cosmic key, a calibration point that synchronized the rhythms of Earth, sky, and human life. This precision is not trivial. At Newgrange, the roof box allows sunlight to reach the farthest recesses of the chamber only for a brief window, adjusted for the axial precession of the Earth over thousands of years. In Peru, the Intihuatana stone at Machu Picchu casts shadows that mark solstice moments, a timekeeping device intertwined with religious observance. At Nabta Playa, archaeologists have identified stone circles and alignments that correspond to the summer solstice sunrise, suggesting the Sahara's prehistoric communities were observing celestial cycles tens of centuries before the pyramids. The repetition of these alignments across continents raises profound questions. Did humans everywhere perceive the turning of the solar year as a sacred moment? Did they, without communication, encode the same cosmic truth into their monuments? And yet, the solstice was not merely a calendar marker. For these civilizations, light itself became a language. The winter sun piercing Newgrange may have symbolized death and rebirth, the triumph of life over darkness. At Chanquillo, the sun's position over the towers may have dictated ritual, planting cycles, or social gatherings. At Giza, the alignment of causeways to the solstice may have fused the spiritual with the mathematical, marking not only the passage of time but the very rhythm of Egyptian cosmology. In every case, the sun was more than a star. It was a guide, a master clock, a force that humans felt compelled to honor and measure. Modern science now allows us to verify what ancient eyes could only intuitively grasp. Satellite-based solar alignment mapping reveals that these sites, scattered across continents, share an extraordinary consistency in their orientation to the solstice sun. 3D modeling and ray tracing confirm that many of these alignments were engineered with precision that challenges assumptions about prehistoric construction methods. Some were aligned within a fraction of a degree, suggesting long-term observation, careful planning, and a sophisticated understanding of geometry and astronomy. The more we study, the more it becomes clear that these monuments are not isolated achievements. They are points in a global constellation of human observation, marking the same cosmic rhythm in disparate cultures. And yet, the ultimate purpose of this alignment remains elusive. Were these sites practical tools, serving as calendars and agricultural guides? Were they sacred spaces, where the ephemeral touch of the sun conferred meaning, power, or ritual significance? Or perhaps, were they part of a broader, almost unconscious human impulse to anchor life to the heavens, to give shape and rhythm to existence itself? The answer may be all of these things. And as we stand today, gazing at the solstice sunrise, we are reminded that the world of our ancestors is not lost. It speaks to us still, across stone and sand, mountain and plain. If you are captivated by this journey, by the mysterious precision and human ingenuity that spans continents, consider joining us in exploring the rest of this extraordinary story. The path from shadow to light has only just begun. In the next moment, we will travel from Ireland's misty tombs to the sands of the Sahara, where the first whispers of a solar code appear, hinting at a human desire to measure, to align, and perhaps to understand the cosmos itself. The precision of ancient monuments is astonishing when viewed through the lens of modern measurement. At Newgrange, the roof box above the tomb's entrance is angled at roughly 6 degrees above the horizontal, perfectly channeling sunlight into the burial chamber during the winter solstice. The beam travels nearly 18 meters along the passage to illuminate the rear chamber for no more than 17 minutes, demonstrating not just an awareness of the solstice, but mastery over geometry, horizon sightlines, and structural proportion. A deviation of a few centimeters in the height of the roof box, or a misalignment of even half a degree in the azimuth, would have sent the sun's rays spilling past the chamber, rendering the effect impossible. Stonehenge exhibits similar precision, though on a monumental scale. The main axis of the trilithons aligns to the northeast, pointing to the sunrise of the summer solstice. The sunset of the winter solstice falls along the same axis in the opposite direction. Measurements of the central avenue show an orientation of approximately 49 degrees east of true north. Surveys have found that the sarsen stones, some weighing over 25 tons, were positioned with an angular accuracy within 0.2 degrees. The builders achieved this without modern instruments, relying instead on repeated observation, rudimentary sighting rods, and simple geometry, a feat that still defies full comprehension. In the deserts of Peru, Chanquillo offers a more dynamic approach to tracking the sun. 13 towers, each roughly 6 to 7 meters high, span the crest of a ridge over 300 meters. From fixed observation points at the base of the ridge, the sun appears to rise behind a different tower each day, creating a full-scale solar calendar. The towers are spaced with a precision of 1 to 2 meters relative to the horizon, allowing observers to track the sun's motion with an accuracy of 1 or 2 days per month. Over the course of the year, the solstices mark the extremes of sunrise positions behind the first and last towers, a natural calendar encoded in stone. To verify such alignments, modern archaeoastronomers employ several methods. First, surveying instruments such as theodolites and total stations measure azimuth and altitude with sub-degree accuracy. These readings determine the orientation of passages, stones, or towers relative to the horizon and cardinal directions. Second, three-dimensional modeling allows researchers to reconstruct the original site, including terrain and horizon variations that may have shifted over millennia. Ray tracing simulations project the path of sunlight on specific dates, confirming whether light reaches its intended target. By combining these tools, archaeologists can test hypotheses about solstice alignments with remarkable precision. Numerical examples underscore the sophistication of these ancient constructions. At Newgrange, the azimuth of the passage aligns at 131.5 degrees for winter solstice sunrise, with the roof box's vertical angle precisely tuned to allow the first rays to enter the chamber. Stonehenge's main trilithon alignment at 49 degrees east of north corresponds to a winter solstice sunset azimuth of 229 degrees, adjusted for the slight axial tilt of Earth at 2500 BCE. At Chanquillo, The first tower aligns to the winter solstice sunrise at an azimuth of roughly 113 degrees, and the final tower to the summer solstice sunrise at 247 degrees, marking the solar extremes with accuracy unattainable without decades of observation. These achievements are even more remarkable when we consider the technological limitations. Builders had no telescopes, no clocks, no modern surveying tools. They relied on direct observation, the rising and setting sun, the changing length of shadows, and geometric intuition passed across generations. At Newgrange, evidence suggests that observers may have used simple posts along the horizon to mark the sun's position each day, gradually refining the alignment over decades. At Stonehenge, the placement of each sarsen and bluestone likely required repetitive sighting along long sight lines, balancing weight and stability while maintaining angular precision. Chankilo's towers, spaced across a ridge, demanded careful measurement of horizontal distances and angles, ensuring the sun would traverse the markers in predictable increments. Archaeoastronomers also use statistical analysis to distinguish deliberate design from coincidence. When comparing dozens of megalithic sites across Europe, South America, and Africa, researchers calculate the probability of observed alignments occurring randomly. The results are striking. At Stonehenge, Newgrange, and Chankillo, the likelihood that solstice alignments occurred by chance is less than 1 in 1,000, strongly suggesting intentional design. Even in cases where horizon irregularities or later landscape changes complicate calculations, the pattern of solar orientation across multiple independent sites consistently exceeds chance, supporting the hypothesis that these cultures deliberately encoded the solstice. The functional implications of such alignments were manifold. Solstice-aligned chambers could serve as ritual spaces, agricultural calendars, or ceremonial markers. At Newgrange, the solstice sunrise may have signaled a symbolic rebirth, marking the return of longer days and the renewal of life cycles. Stonehenge's alignment could have coordinated communal ceremonies and reflected an intricate understanding of the solar year. At Chankillo, the tower calendar allowed precise tracking of the sun for agricultural purposes, ensuring planting and harvesting aligned with optimal seasonal conditions. Across these sites, the alignment of stone and light becomes both practical and symbolic, a marriage of observation and meaning. The precision also raises profound questions about human cognition and cultural convergence. How is it that societies separated by oceans, mountains, and deserts, with no known contact, converged on the same solar event as a focal point for architecture and ritual? The answer may lie in the universality of the sun itself. Regardless of geography or language, humans everywhere experience the same annual cycle, the same shifting length of days, the same sunlit apex and nadir. The solstice, as a natural marker, may have instinctively drawn attention, guiding observation, innovation, and construction. Yet the similarities go beyond function. The architecture itself reflects shared principles of geometry, observation, and foresight. Newgrange's roof box demonstrates acute understanding of vertical and horizontal angles. Stonehenge embodies modular geometry and precise alignment to distant horizons. Chankillo translates daily solar motion into a physical, measurable sequence. Each culture, independently, mastered the tools at their disposal to measure and manipulate light and shadow with extraordinary care. These are not rudimentary observances, but evidence of deliberate, sustained engagement with the sky. Modern technology continues to uncover new layers of understanding. Satellite mapping enables the comparison of alignment patterns across continents, revealing that many solstice-oriented sites cluster along similar latitudinal ranges where horizon angles and sun arcs produce dramatic light effects. Three-dimensional scanning of chambers and towers has identified subtle refinements, slight tilts, precise spacing, and carefully angled surfaces that maximize illumination at solstice moments. Even the smallest details, such as a carved spiral inside Newgrange or the spacing between Chankillo towers, are revealed as critical components of an integrated observational system. The effect on the observer must also be considered. For an individual standing inside a solstice-aligned chamber or at a calculated observation point, the experience is visceral. Sunlight suddenly filling a dark, enclosed space, shadows retreating in unison, a clear visual confirmation of the solar cycle. Across time, these precise interactions between light, stone, and human perception may have fostered awe, reverence, and a sense of cosmic order. This connection between measurable precision and human experience underscores why the solstice, encoded in stone, became central to ritual and society. Ultimately, the sun itself acts as a universal reference point, a constant across geography and history. The repeated appearance of solstice-aligned monuments suggests that ancient humans, separated by thousands of miles and centuries, were independently drawn to the same cosmic rhythm. Their monuments are records not just of skill, but of perception, observation, and a shared impulse to anchor human life to the turning of the world. And yet, the mystery deepens. We have instruments to measure alignments, models to simulate light paths, and statistical methods to confirm intent. But the deeper purpose remains enigmatic. Were these structures simply calendars and markers, or did they encode a more profound understanding of the universe, a hidden knowledge lost to time? The sun, in its unwavering arc across the sky, may have left a pattern in stone, a message that spans continents, a code waiting to be deciphered. The world is vast, yet across it, the turning of the sun's path has left fingerprints in stone, sand, and mountain. From the mist-shrouded hills of Ireland to the arid deserts of Peru, ancient humans seemed compelled to mark the same celestial rhythm. But what does it mean that societies, separated by thousands of miles and millennia, independently observed the solstice with such care? Could there be an invisible thread connecting these disparate cultures, or is it merely the inevitable outcome of living under the same sky? Consider Europe first. Beyond Stonehenge, monuments such as Durrington Walls and Avebury trace solar arcs along vast ceremonial avenues. Measurements reveal alignments consistent with solstice sunrise and sunset. Some of these avenues stretch for kilometers, their endpoints marked by wooden posts or standing stones, long vanished in the centuries since. Using laser scanning and horizon modeling, researchers have determined that the precision of these alignments reaches within a degree of the actual solstice points. The repeated accuracy across multiple sites suggests a deliberate cultural focus on solar events rather than mere coincidence. Meanwhile, in Africa, the Nubian deserts of the Sahara hide earlier patterns. At Nabta Playa some 7,000 years ago, prehistoric communities erected stone circles aligned to the summer solstice sunrise. Surveys indicate the alignment falls within 1 to 2 degrees of the true horizon position. The stones themselves, often just human height markers, were placed with painstaking repetition to track the sun's motion across the horizon. Here too, the solstice was not a solitary observation, but a practical and ritual tool, guiding water collection, seasonal migration, and social cohesion. A question arises: did the African solstice monuments influence Europe, or was this an entirely independent solution to the same astronomical problem? Across the Atlantic, the Americas present another remarkable story. The Incas, with their mountaintop observatories, understood the nuances of shadow and light to track solstice positions. The Intihuatana stone at Machu Picchu, angled to cast shadows only at specific solar positions, demonstrates an understanding of both latitude and axial tilt. In Mesoamerica, the Maya built pyramids that captured precise solstice sunrise and sunset effects. At Uxmal, the Pyramid of the Magician aligns with the winter solstice, its staircases casting shadows that mark the sun's apex. These alignments required repeated observation, measurement, and adjustment, a conscious dialogue with the heavens. Even the deserts of coastal Peru hold Chanquillo, the 13 towers that create a daily solar calendar visible across the ridge. Unlike the ceremonial monuments in Europe or the sacred chambers of Newgrange, Chanquillo's design transforms the landscape itself into a functional instrument. From fixed observation points, the sun appears behind a different tower each day, moving along the ridge in a predictable arc. This allows observers to track the sun's journey with an accuracy of 1 or 2 days per month, and its solstices mark the outer extremes of solar movement. Here is an architecture that blends utility and reverence, practical timekeeping, and ritual awareness. What is striking is not merely the alignment, but the consistency of human observation across cultures. Whether measured in degrees of azimuth, distances between markers, or the length of sunbeams, the precision is extraordinary. At Newgrange, a 6-degree roof box channels light 18 meters to illuminate a chamber. At Stonehenge, trilithons align with winter solstice sunset within 0.2 degrees. At Chanquillo, towers are spaced to match solar extremes with minimal error. Across continents, humans independently developed strategies to measure and encode solar motion, a universal language written in stone. The methods of modern archaeoastronomy reveal just how much these ancient builders understood. Surveying tools, horizon modeling, and statistical analysis allow us to quantify what they achieved. The accuracy of their alignments exceeds what would be expected by chance. Three-dimensional modeling and ray tracing confirm that light would reach precisely the intended targets at solstice, and that even small errors in construction would have prevented the desired effect. In essence, the ancient builders were performing observational astronomy with tools as rudimentary as posts, strings, and careful repetition, yet achieving results that rival our modern simulations. Satellite mapping has added another layer to this global picture. Researchers have identified alignment clusters that span continents, showing concentrations of solstice-oriented monuments at similar latitudes where horizon effects amplify sunlight patterns. In some cases, clusters in Europe, North Africa, and the Americas correspond to regions where solstice shadows or sun arcs create especially dramatic effects at dawn or dusk. These patterns suggest that the solstice may have been chosen not only for its temporal significance, but also for its visual impact, a combination of practical, spiritual, and aesthetic motivation. And yet, despite our ability to measure and model, we are left with a haunting question. Why the convergence? Why do cultures separated by oceans, mountains, and deserts repeatedly fixate on the solstice? Is it instinctual? A recognition that the sun's apex and nadir control life's cycles? Or does it point to a deeper, perhaps universal principle that humans across the globe intuitively understood? Are we seeing the emergence of a shared human impulse, a cognitive response to the same cosmic rhythm? Each alignment tells a story beyond mere astronomy. In the deserts, the solstice could dictate when to plant crops or follow migratory patterns. On mountains, it could mark sacred festivals and ritual ceremonies. In tombs and chambers, the sun's beam might symbolize life, death, and renewal. Across all cultures, the solstice simultaneously measures time, guides activity, and instills awe. This multi-layered purpose suggests that ancient societies viewed the sun not as a distant star, but as a vital axis around which human existence revolves. To align a passage, a circle of stones, or a row of towers within 1 or 2 degrees using observation alone, without instruments, requires patience, iterative measurement, and extraordinary skill. Builders observed the horizon over decades, adjusted their constructions, and incorporated subtle corrections, all without the benefit of telescopes, compasses, or numerical trigonometry. It is a testament to human ingenuity, curiosity, and dedication, and it raises a further question. If these techniques emerged independently in multiple regions, are we glimpsing a universal cognitive thread in human history? The philosophical implications are compelling. The solstice emerges as more than a temporal marker. It is a point of convergence, a natural constant that humans everywhere encoded in stone. By marking the sun's turning point, disparate cultures may have been tuning their calendars, rituals, and social systems to the same cosmic rhythm. Could it be that the winter solstice functioned as the first global standard, a natural calibration point understood instinctively by humans before formalized science or writing? And yet, the patterns we observe are only the beginning. Across continents, subtle variations hint at local adaptation and innovation. Newgrange's roof box angles differ slightly from Chanquillo's towers. Machu Picchu's Intihuatana interacts with latitude-specific solar arcs, and Stonehenge's trilithons reflect northern horizon geometry. Each solution is unique, yet all converge on the same celestial event. It is as though humanity, everywhere, is reading from the same cosmic manuscript, interpreting the solstice in forms dictated by geography, culture, and ingenuity. As we step back to observe the planet from above, the sun becomes not just a star but a measuring stick, a universal clock, and a symbol bridging oceans and epochs. Its arc, unchanging in its broad pattern yet nuanced in local effect, imprinted on humans a need to observe, measure, and encode. We see the first threads of a global pattern, monuments aligned, calendars synchronized, rituals timed, and yet the knowledge remains fragmentary, scattered, tantalizingly incomplete. And so we reach the threshold of discovery. The solstice is more than a day marked in stone. It is a key to understanding the evolution of human thought, observation, and shared cosmic awareness. But the sun may reveal even more. A code, perhaps, that extends beyond the monuments themselves. Hidden in light and shadow across continents and millennia may lie a systematic record of knowledge, an unwritten, universal language. What will we find as we decode it further? What does it mean that the same day, the shortest of the year, was elevated to sacred, practical, and cosmic significance across the globe? The answer may lie in observing not a single site, but the totality of aligned monuments, a constellation of human intention written in stone, guided by the path of the sun. The journey continues, and the next revelations may illuminate more than just stone and shadow. They may illuminate the mind of humanity itself. Every year, the Earth tilts slightly on its axis, and for a brief moment, one hemisphere leans furthest from the sun. The days are shortest, the nights longest, and a subtle, almost imperceptible magic marks the turning of the seasons. For the ancients, this was not a scientific calculation. It was a palpable event, felt in the cold air, observed in shadows, measured in the slow retreat of daylight. The winter solstice was more than a day. It was a signal, a turning point, a cosmic punctuation in the rhythm of life. The astronomical mechanics behind this are elegantly simple and yet profoundly precise. The Earth's axial tilt of 23.5 degrees causes the sun to trace a shifting path across the sky over the year. On the winter solstice, the sun rises at its southernmost point along the horizon and sets at its southernmost point in the west. The angle of the sun at noon reaches its lowest, and shadows stretch longest. These changes are subtle over days and weeks, but unmistakable when measured against landmarks, mountains, or constructed markers. For ancient observers, the solstice was predictable, repeatable, and essential, the natural clock around which they organized life. In Newgrange, the solstice sunrise was not just a marker of time, it was an event carefully engineered into the tomb itself. The chamber's roof box allows sunlight to penetrate exactly along the passageway, illuminating carvings that may symbolize rebirth. Across Europe, similar phenomena were recorded in stone circles and avenues. At Durrington Walls, the alignment of post holes points to the rising sun on the shortest day of the year. Even subtle adjustments in horizon altitude were accounted for, suggesting that builders observed the sun's annual path over decades before finalizing construction. The winter solstice's significance was not limited to ritual. It provided a practical guide to agriculture, allowing communities to track the seasons and predict the cycles of planting and harvest. In the deserts of northern Africa, the solstice sunrise aligned with stone markers at Nabta Playa, guiding nomadic populations in synchronizing grazing, water collection, and seasonal migration. In the highlands of Peru, the Incas could rely on Intihuatana stones to determine the precise moment when the sun reached its nadir, planning festivals, planting, and ceremonial events around this cosmic anchor. This dual role, practical and sacred, is reflected in architecture across cultures. At Machu Picchu, terraces, temples, and plazas were all arranged to interact with sunlight in precise ways. During the solstice, certain staircases cast shadows that fall exactly on specific stones, marking time without written calendars. At Chanquillo, the 13 towers do not merely track the extremes of solar motion, they offer a daily progression, allowing observers to calculate the sun's position at any point in the year. These constructions demonstrate that the solstice was understood as both a moment and a system, a guide for human life encoded in stone. The Maya provide another perspective. Pyramids such as El Castillo at Chichen Itza interact with sunlight to create striking visual effects. On the equinoxes, a series of shadows cast along the pyramid staircase resembles a serpent slithering toward the ground. While this phenomenon occurs during the equinox, the same attention to solar movement appears in solstice alignments. Pyramids, plazas, and observatories are deliberately positioned so that the sun's shadow interacts with architecture to signal sacred dates. The precision is not symbolic alone. It reflects careful observation and long-term recording of solar cycles. Even Giza's pyramids reveal solar sophistication. Recent studies suggest that the causeways connecting the pyramids to the Nile were oriented to align with solstitial points. While the Great Pyramid's axis is aligned nearly perfectly to true north, the surrounding landscape and pathways may have functioned as solar markers, integrating celestial cycles with ritual and statecraft. By linking monumental architecture to solar patterns, ancient builders created systems that were both precise and imbued with cultural meaning. How then did societies so widely separated achieve such accuracy? Modern analysis reveals the methods in broad terms, though the details of their process remain shrouded in mystery. Observation was paramount. Across continents, communities likely tracked the sunrise and sunset over months and years, using posts, stones, or mountains as reference points. Repeated measurements allowed them to refine their constructions, accounting for horizon variations and seasonal shifts. Geometry, too, was employed intuitively. Straight sightlines, right angles, and proportional spacing enabled the sun's rays to strike precisely where intended. Some alignments were astonishingly accurate. At Chanquillo, the towers mark the sun's extreme positions with an azimuth difference of approximately 134 degrees at the winter solstice and 246 degrees at the summer solstice. The spacing of towers is accurate to within 1 or 2 meters, sufficient to ensure the sun appears behind the correct tower on the correct day. At Newgrange, the roof box's vertical angle is calibrated so that sunlight travels a passage 18 meters long, illuminating the chamber for only 17 minutes at the precise moment of the solstice sunrise. At Stonehenge, the trilithon axis points toward the summer solstice sunrise at roughly 49 degrees east of north, adjusted for axial tilt at the time of construction. These examples illustrate an astonishing understanding of angles, distance, and timing, all achieved without written trigonometry. What emerges is a vision of human beings intimately connected to the sky. The solstice is not merely a point in time, but a measure of existence itself. It dictates seasons, guides rituals, and fosters shared cultural memory. And yet, across all these cultures, the solstice conveys more than utility. It speaks to the human desire to link the mundane and the cosmic, to see daily life as part of a greater rhythm. The construction of monuments, the careful orientation of passages, the deliberate shaping of light and shadow, These acts are evidence that humanity recognized a higher order, one that transcended individual culture or geography. Even small variations between sites reveal a sophistication of local adaptation. Latitude, horizon altitude, and terrain influenced how the solstice was observed and encoded. In Ireland, the low winter sun requires precise vertical angles to illuminate tomb chambers. In Peru, the high Andes produce longer shadows and sharper solar arcs, prompting terrace and tower design to account for both angle and altitude. In the Maya lowlands, seasonal cloud cover and atmospheric conditions shaped the choice of architecture and alignment. Every construction is a response to the specific intersection of sky, landscape, and human observation, yet the central principle remains constant. The solstice governs light, and light governs human measurement of time. Beyond architecture, the solstice appears in cultural symbolism and ritual. In European contexts, the solstice often coincided with feasts, ceremonies, and communal gatherings. In the Americas, solar festivals marked sacred calendars, integrating agricultural cycles with religious observance. In Africa, the solstice may have signaled the beginning or end of water-dependent migrations or ceremonial cycles. Across all these manifestations, the sun's return after the longest night became a metaphor for renewal, continuity, and the persistence of life. And as we examine these monuments from above, mapping latitude, azimuth, and horizon interactions, a pattern becomes clear. The solstice was a shared focal point for human attention. Even in the absence of contact or communication, societies independently encoded the same event with extraordinary precision. It is a convergence of observation, cognition, and cultural expression, a phenomenon that raises profound questions. Are we witnessing instinctive responses to universal celestial cycles, or the earliest form of a shared human understanding of the cosmos? Could the solstice have served as the first truly global marker of time, a natural standard recognized across oceans and continents? The answer may lie in the combination of practice and awe. Ancient peoples did not merely measure the sun. They engaged with it. They observed, waited, adjusted, and refined. They carved passages, erected towers, and aligned massive stones, not simply to survive, but to understand their place in the universe. The solstice offered a tangible connection between human life and celestial motion, a constant anchor in an ever-changing world. And so, as the winter sun rises and sets with unerring rhythm, we are left to ponder the implications. The solstice is at once a scientific phenomenon and a profound cultural touchstone. It shapes the monuments of humanity, it measures time, and it reflects a shared cosmic awareness that transcends borders, language, and epoch. In watching how light strikes stone, shadow traces stone, and stone honors light, we begin to see that the solstice was far more than a day on the calendar. It was a bridge between the earthbound and the celestial, a marker of the universal order that human beings have always sought to comprehend. Across the vast span of human history, some monuments have stood as silent witnesses to a level of precision that continues to baffle modern engineers. The question is not merely how these stones were moved or placed, but how entire structures were oriented with almost mathematical exactness to the paths of the sun, centuries before the development of formal astronomy or complex instruments. At first glance, the achievements at Stonehenge, Newgrange, Chanquillo, Machu Picchu, and even the pyramids of Giza might appear to be isolated instances of ingenuity. Yet when viewed together, they reveal a startling pattern. Ancient humans mastered techniques that allowed them to encode celestial motion with astonishing accuracy. Take the trilithons of Stonehenge. Each sarsen block, weighing upwards of 25 tons, was positioned to align along a northeast-southwest axis corresponding to the solstices. Archaeoastronomers such as Gerald Hawkins in the 1960s and more recent surveys by Clive Ruggles and colleagues have calculated that the alignment accuracy is within 0.2 degrees of the solstice sunrise and sunset azimuths of the period around 2500 BCE. To achieve such precision without compasses or chronometers implies an advanced system of repeated observation and geometric calculation. Researchers hypothesize that the builders may have used shadow gnomons, vertical posts whose shadow tips were tracked across days and seasons to determine angles of solar rise and set. By combining repeated observation with simple triangulation, prehistoric engineers could have translated the motion of the sun into architectural alignments. At New Grange, the winter solstice roof box provides another layer of technical sophistication. The passage to the chamber stretches nearly 19 meters, and the roof box is calibrated so that sunlight enters the chamber for only 17 minutes at sunrise. Measurements by Michael O'Kelly and later by archaeologists using laser scanning confirm that a deviation of even 10 centimeters or half a degree would disrupt the effect entirely. Researchers such as A.J. Woods have suggested that this level of precision required not only careful observation over many years, but also an understanding of geometric projection and light reflection. The tomb's builders may have employed rudimentary sightlines, posts along the horizon, and iterative adjustment, yet the result is indistinguishable from modern computer-generated simulations. Chanquillo in Peru presents a more dynamic system. The 13 towers stretching along a ridge act as a full-year solar observatory. Researchers from the Universidad Nacional de Trujillo measured the horizon azimuths for each tower, discovering that the spacing allows the sun to appear behind a specific tower on almost every day of the year. The summer and winter solstice extremes correspond to the first and last towers with a precision of less than 2 meters of horizontal error. It has been proposed that observers may have marked these positions using sighting poles or simple chord triangulation. What is striking is the accuracy achieved without formal mathematics, a functional calendar embedded directly into the landscape. Similar ingenuity is visible in Machu Picchu, where the Intihuatana stone interacts with solar angles to indicate solstice positions. Measurements by Johann Reinhard and others show that the stone casts minimal shadow at midday during the winter solstice, functioning as a solar gnomon. The terraces, temples, and plazas are aligned to capture these precise shadow patterns, suggesting that the architects understood not only the movement of the sun across the sky, but also its interaction with altitude, latitude, and slope. This is corroborated by studies using 3D scanning and digital elevation models, which confirm that the alignment of terraces maximizes sunlight exposure at key seasonal points. Even Giza, the epitome of ancient precision, demonstrates knowledge that rivals later civilizations. The Great Pyramid sides are aligned within 0.05 degrees of true north, an achievement verified by Robert Bauval and subsequent satellite surveys. Some Egyptologists, including Kate Spence, have hypothesized that the builders used the circumpolar stars as a reference, specifically observing the simultaneous transit of Kokab and Mizar around 2500 BCE. By marking the vertical alignment of these stars, the Egyptians could set a remarkably accurate north-south axis. The solstice may have then been used as a secondary calibration point, ensuring that the pyramid's passageways and chambers aligned with solar phenomena. Modern techniques confirm the sophistication of these alignments. Ray tracing software allows researchers to simulate the movement of sunlight and shadow at any historical date, accounting for precession, atmospheric refraction, and horizon changes. 3D laser scanning permits measurement of structural angles to millimeter accuracy, revealing subtle corrections, deliberate deviations, and architectural refinements. Statistical modeling shows that the probability of these solstice alignments occurring by chance is vanishingly small. Across multiple sites, the cumulative likelihood of coincidence drops to less than 0.1%, reinforcing the conclusion that ancient engineers understood and encoded solar patterns deliberately. Beyond alignment, the methods used to achieve such precision suggest a broader understanding of geometry, measurement, and long-term observation. For example, triangulation may have been employed. By establishing a baseline between two known points and sighting a third along the solstice sunrise, builders could calculate distances and angles over tens or hundreds of meters. Simple instruments, such as gnomons or chords marked with unit lengths, could have enabled iterative refinement. Ethnographic analogues in traditional societies show that careful horizon observation, combined with repeated measurement, is sufficient to achieve remarkable solar accuracy, a principle apparently applied independently across continents. Another hypothesis emerging from recent research is that these alignments were not merely observational, but also encoded energy or cosmological concepts. Some archaeoastronomers, including Clive Ruggles and Giulio Magli, suggest that solstice-aligned structures may have served as focal points for social cohesion, ritual, and even the channeling of natural energies. Light entering tombs or illuminating ceremonial stones at exact times could have reinforced symbolic ideas of life, death, rebirth, and cosmic order. At Newgrange, the beam of sunlight may have symbolized a connection between the living and ancestors. At Chankillo, the steady tracking of the sun may have synchronized communal activities and reinforced a shared understanding of time and ritual. Interestingly, numerical modeling of horizon effects reveals that solstice precision was latitude-dependent. Sites at higher latitudes, such as Ireland or northern Scotland, required acute attention to vertical angles due to low sun arcs, while equatorial or Andean sites had to account for rapid changes in sun altitude and slope shading. This reinforces the idea that ancient builders were not relying on generic rules, but observed and measured their environment carefully, adjusting their structures to local conditions. Even small errors in alignment would have been visually noticeable, suggesting a process of repeated observation and correction over years, perhaps even generations. These techniques were not isolated. Across Europe, Africa, and the Americas, there are patterns of construction that suggest shared principles: horizon observation, light-shadow interaction, geometric proportion, and repeated measurement. While direct contact between cultures is implausible, the convergence of methods indicates that human cognition and practical necessity led independently to remarkably similar solutions. In other words, the sun became the universal teacher, and humanity learned to read its movement with ingenuity, patience, and artistry. The philosophical implications are profound. The monuments themselves become evidence of a shared human impulse to measure, to observe, and to anchor life to the cosmos. Precision was not a mere technical exercise, it was a form of communication with the universe. By encoding solar patterns into stone, humans created enduring records of observation, intention, and understanding, anticipating modern astronomy by millennia. The solstice, then, is not just an astronomical event, but a lens through which we can glimpse the minds of our ancestors. And yet the mystery deepens. Across continents, cultures developed similar techniques independently, suggesting a cognitive universality in understanding celestial motion. They achieved alignment with a degree of precision that challenges our assumptions about prehistoric technology. Whether through gnomons, sightlines, chords, or observation of circumpolar stars, the ancients engineered the impossible, structures that not only stand against time, but also encode a sophisticated awareness of the cosmos.
As we step back to consider these feats collectively, one question looms. If humans, separated by oceans and mountains, independently mastered the measurement of sunlight and shadow with such precision, what else might have been encoded in stone? Were these monuments simply calendars, or did they also hold knowledge of energy, cosmology, and natural cycles that we have yet to fully comprehend? The evidence points to deliberate calculation, iterative measurement, and an extraordinary understanding of the sun's movement, an understanding that surpasses what we often imagine for prehistoric societies. Across the ancient world, the winter solstice marked a moment when the sky dictated the rhythm of human existence. At Newgrange, for example, the illumination of the chamber at sunrise was not only a technical achievement, but also a signal embedded into the very fabric of communal life. Archaeologists suggest that these solar events were linked to seasonal festivals, during which the local population gathered to exchange goods, perform rituals, and reinforce social hierarchies. Carbon dating of hearths and ceremonial artifacts indicates that these gatherings coincided with the solstice, turning the astronomical event into a focal point for social cohesion and cultural memory.
In the deserts of northern Africa, the inhabitants of Nabta Playa developed stone circles aligned with the solstice, which likely played a role in agricultural and pastoral planning. Studies of pollen records and sediment cores reveal that these communities practiced early forms of seasonal rotation, relying on precise observation of the sun to determine when to herd cattle and sow crops. In this context, the solstice functioned as a natural calendar, a shared temporal reference around which complex subsistence strategies were organized. Such alignment was not an abstract exercise, but a practical tool that directly affected survival and social order. The Inca of the Andes provide another vivid example. Machu Picchu's terraces and Intihuatana stone were designed to interact with sunlight, marking critical points in the agricultural cycle. The timing of solstice observation informed when to plant maize and other crops suited to the mountain microclimates. Records from chroniclers such as Pedro Sarmiento de Gamboa and studies by Johann Reinhard indicate that solstice ceremonies also reinforced political authority. The Inca rulers' ability to predict and control the sun's movements elevated their status as intermediaries between the heavens and the people, integrating celestial knowledge with governance and societal structure. Further east, Chanquilo's 13 towers served not only as a solar calendar, but also as a tool for regulating trade and labor. Archaeologists analyzing settlement patterns near the site have suggested that knowledge of the solar cycle enabled organized labor rotation and the scheduling of communal agricultural activities. The towers provided a daily reference point, allowing farmers and herders to plan tasks months in advance, aligning human activity with the natural rhythm of the sun. In this way, the solstice was encoded into both the architecture and the social fabric, a universal calibration point linking celestial motion with human life. In Europe, the solstice's cultural imprint is equally profound. At Stonehenge, the surrounding landscape contains pits, avenues, and smaller stone settings that researchers believe served both ceremonial and timekeeping functions. Excavations at Durrington Walls indicate that solstice events were accompanied by large feasting and gatherings, possibly coinciding with the end of winter scarcity. Analysis of animal bones, pottery, and charred grain suggests coordinated procurement and preparation, highlighting the solstice as an organizational anchor for society. The sun's return was not merely observed, it structured labor, ritual, and exchange, embedding astronomical knowledge into the communal lifestyle. Even the Maya integrated solstice observation into urban planning and civic life. In cities such as Uxmal and Copan, the positioning of pyramids, plazas, and observatories aligns with solar extremes, guiding the timing of markets, religious festivals, and ceremonial games. Iconography and glyphs suggest that priests monitored these alignments to maintain calendars and perform divinatory functions, linking cosmic cycles to social governance. The solstice thus served as a regulator, connecting daily life to seasonal and ritual imperatives. Recent archaeoastronomical research reinforces this concept of a universal calibration point. Satellite imagery and GIS-based surveys reveal clusters of solstice-aligned monuments along specific latitudes and longitudinal corridors, suggesting that societies recognized both solar extremes and their local environmental context. These alignments were not random. They intersected with rivers, valleys, and mountain passes, allowing societies to synchronize movement, trade, and agricultural practices with predictable solar cycles. By encoding these rhythms in architecture, humans effectively created a spatial temporal map that linked society to the celestial order. Beyond calendars and agriculture, solstice observances reinforced shared belief systems. Light penetrating the chamber at New Grange, for instance, likely carried symbolic significance of renewal, ancestral presence, and cosmic order. At Machu Picchu, rituals performed at Intihuatana stones emphasized harmony between humans and the mountains, which were considered sacred. At Stonehenge, the alignment of avenues and stones framed not only solar observation but communal ritual, binding participants together in a shared understanding of their place in the cosmos. Across cultures, the solstice became both a temporal anchor and a philosophical touchstone, a moment when society could witness the consistency of celestial order and its reflection in human life. Furthermore, ethnographic analogies provide insight into how prehistoric communities may have used solstice knowledge. Contemporary indigenous societies in the Andes, the Sahara, and parts of Europe observe solar extremes to regulate festivals, migration, and seasonal labor. The accuracy and consistency of these practices suggest that ancient methods were not lost, but were deeply embedded in societal routines. By observing solar motion, communities could synchronize work, ritual, and celebration across vast spaces and over generations. The solstice was, in effect, a master clock, linking human activity to the universal rhythm of the sun. The precision required for these alignments also hints at social organization and transmission of knowledge. Maintaining the Chanquillo Towers or the roof box at Newgrange would have required repeated measurement over years, careful recording, and perhaps a specialist class of observers or priests. Similarly, Machu Picchu's terraces demonstrate coordination of labor informed by celestial observation. This suggests that solstice knowledge was embedded not just in architecture, but in social structure, guiding roles, responsibilities, and cultural memory. The sun became a central axis around which both material and societal structures revolved. In this light, the solstice emerges as a universal calibration point in multiple dimensions: timekeeping, agriculture, ritual, and governance. Its significance transcended mere observation. It became a framework for organizing life itself. Societies independently discovered that marking the sun's extremes allowed them to regulate activity, maintain calendars, and create shared systems of meaning. The monuments, far from static, were instruments of knowledge, culture, and social cohesion, encoding the sun's motion into the daily and seasonal rhythms of civilization. By studying these monuments collectively, patterns emerge. Despite vast differences in geography, climate, and culture, humans repeatedly turn to the solstice as a reference point. This convergence implies that the solstice fulfilled a universal human need, a natural marker around which to measure time, organize society, and align life with the cosmos. The alignment of human activity with celestial motion was not incidental. It was an intentional, multifaceted strategy integrating observation, architecture, and culture. And as we reflect on these achievements, we are compelled to reconsider the role of the sun in shaping human history. The winter solstice was more than a day. It was a cornerstone of civilization, a temporal and cultural anchor connecting survival, ritual, and shared human cognition. Across continents, the sun's turning point provided guidance, structure, and meaning, encoding into stone and social practice a universal principle that human life is inseparable from the rhythm of the heavens. In the heart of prehistoric Europe, communities around 3000 to 2500 BCE left behind monuments whose stones still speak to us today. Stonehenge, Durrington Walls, and the surrounding henges are not merely architectural feats. They are windows into a complex, ritualized society that use the sun to structure not just their year, but their very identity. Historians like Barry Cunliffe and archaeologists such as Mike Parker Pearson have painstakingly reconstructed aspects of this culture, drawing on excavation evidence, carbon dating, and ethnographic analogies. What emerges is a society where observation of the heavens and human behavior were inseparably intertwined. The solstice dictated social rhythm. At Durrington Walls, evidence of large-scale feasting, animal bones, charred cereals, and pottery fragments reveals that communities congregated during key solar events. Cunliffe notes that these gatherings were not spontaneous, but planned with remarkable coordination, suggesting a hierarchical structure capable of mobilizing hundreds of people. The solstice may have served as both a temporal anchor and a social catalyst, enabling long-distance trade, exchange of goods, and reinforcement of communal identity. People traveled from miles around to participate, marking the sun's return with ritualized consumption, storytelling, and ceremonial observances. Beyond feasting, these communities encoded solar observation into their daily labor. At Stonehenge, the orientation of stones aligns with sunrise on the summer solstice, while smaller surrounding pits and avenues suggest that seasonal agricultural work was guided by the sun's position. Parker Pearson argues that the solar alignment may have functioned as a communal calendar, regulating planting, harvesting, and herding schedules. Archaeological surveys of nearby fields and settlements show that crop remains align with this timeline, indicating that the sun's movement was translated into practical, seasonal planning, a fusion of cosmology and survival. Ritual practice extended beyond agriculture. The Neolithic societies of southern Britain appear to have invested symbolic significance in the sun's movement. Excavations of the Amesbury Archer site, combined with isotope analysis and burial artifacts, indicate a society deeply conscious of lineage, ancestry, and cosmic order. High-status burials suggest that certain individuals may have been responsible for tracking the sun and organizing communal observances. Researchers like Julian Thomas have proposed that these figures acted as intermediaries between the community and the celestial cycles, interpreting the sun's movement to guide both ritual and social governance. The construction techniques themselves reflect cultural priorities. At Stonehenge, the selection of sarsen stones from the Marlborough Downs, over 25 kilometers away, and bluestones from Preseli Hills, more than 200 kilometers distant, demonstrates extraordinary logistical coordination. Parker Pearson interprets this as a reflection of social cohesion and religious motivation. The act of transporting stones, erecting them along precise solstitial axes, and maintaining the site over generations reinforced both communal effort and shared belief. The solstice was not a passive event. It was an active cultural project embedded into the society's identity. Other ceremonial sites, such as Callanish in Scotland, reveal additional layers of social and spiritual practice. Excavations and alignment studies by Clive Ruggles show that the Callanish stones interact with both summer and winter solstice light, casting long shadows that sweep across the landscape. Anthropological analysis suggests that these shadows may have demarcated sacred zones, guiding participants in ritual processions or determining the placement of offerings. The alignment of these stones reflects an intimate knowledge of both topography and celestial motion, combined with symbolic intention. The solstice was a performance, a choreography of light and stone that structured communal experience and conveyed cultural meaning. The archaeological record also shows that these practices were intergenerational. Carbon-dated hearths, pottery styles, and burial sequences indicate that knowledge of solstice observation was preserved and transmitted across centuries. This continuity suggests that prehistoric European societies had formalized methods for teaching, measuring, and recording solar motion. As Parker Pearson emphasizes, the consistency of alignments over time points to an institutionalized understanding of astronomy within cultural practice, likely tied to religious or ceremonial leadership. The sun's path became a living framework for memory, authority, and identity. Historical accounts, though much later, offer glimpses into how these cultural practices may have been interpreted by subsequent generations. Roman chroniclers describe the reverence of local communities for solstitial celebrations, hinting at continuity in ritual focus even after large-scale societal changes. This aligns with archaeological evidence that monuments such as Stonehenge remained sites of cultural significance for centuries after initial construction. The winter and summer solstices continued to serve as markers for ritual gatherings, reinforcing social bonds, redistributing resources, and honoring the cycles of life and death. Even dietary evidence supports the integration of solar observation into daily life. Analysis of animal remains from Durrington walls and nearby settlements shows that feasting was timed to coincide with solstitial gatherings. Cattle and pig bones, along with charred cereals, suggest both seasonal abundance and ceremonial consumption. This indicates that astronomical knowledge was practical. Predicting the sun's position ensured optimal timing for livestock culling, harvests, and communal feasts. In this sense, the solstice bridged the sacred and the practical, uniting cosmology with the necessities of subsistence. The European Neolithic sun cult, as reconstructed through archaeology, demonstrates a society where solar observation was central to culture, governance, and daily life. The solstice dictated when communities gathered, when crops were sown and reaped, and when rituals affirmed both cosmological and social order. The precision of alignments reflects technical skill, while the scale of construction and evidence of communal effort reflects cultural priorities. By studying these practices, we gain insight not merely into architecture, but into the worldview of ancient Europeans, a worldview where survival, spirituality, and social cohesion were inseparable from the movement of the sun. And while much about these societies remains hidden, the traces in stone, bone, and soil reveal a sophisticated cultural integration. Humans attuned their lives to celestial rhythm, organized their labor around predictable cosmic events, and embedded meaning into the landscape itself. The winter solstice was not a solitary event. It was a nexus where astronomy, ritual, and social structure converged, shaping not only the calendar but the very culture of prehistoric Europe. Now imagine standing before a mound of stone in the damp Irish morning, the wind carrying whispers of centuries past. Newgrange is more than a tomb. It is a testament to a society that wove celestial precision into the fabric of life. Constructed around 3200 BCE, it predates Stonehenge by centuries, yet its roof box allows the winter solstice sun to penetrate its chamber with pinpoint accuracy. For the Neolithic builders, this was not mere decoration. It was a message, an interface between the cosmos and human experience. The sunlight that fills the chamber each December is a fleeting phenomenon, lasting only 17 minutes. Yet in that brief illumination, life, death, and rebirth converge in an orchestrated ritual that shaped the society surrounding the monument. Archaeological investigations led by Michael O'Kelly in the 1960s revealed that Newgrange was part of a broader cultural landscape of tombs, henges, and ritual sites along the Boyne Valley. O'Kelly's surveys, confirmed by more recent LiDAR scans and ground-penetrating radar, indicate that the mound's construction required a sophisticated understanding of angles, horizon profiles, and seasonal solar motion. Historians such as George Yogan further emphasize that this level of precision reflects years of observation and communal effort, suggesting a class of individuals, astronomer priests or ritual specialists, tasked with encoding celestial knowledge into stone. Yet Newgrange was not solely a monument to observation. It was deeply interwoven with cultural practices. Excavations have uncovered pottery, polished stone axes, and human remains indicating complex burial rituals. Some scholars, including Peter Harbison, proposed that the solstice light symbolically reanimated the deceased, merging agricultural cycles with human life cycles. Feasting, suggested by burnt animal bones and charred plant remains in surrounding pits, coincided with solstice events, reinforcing community cohesion. Seasonal gatherings would have facilitated exchange, cemented alliances, and transmitted cultural memory, all synchronized with the movement of the sun. Interestingly, the orientation and placement of Newgrange within the valley suggest a broader awareness of landscape cosmology. Its roof box is angled to catch the winter solstice sunrise over the distant hills, implying long-term observation of both topography and solar motion. Recent archaeoastronomical studies using digital horizon models show that even slight deviations in elevation would disrupt the phenomenon, highlighting the meticulous planning involved. This indicates not just observational skill, but a cultural imperative. Aligning human structures with celestial cycles was a societal priority. Life around Newgrange was similarly structured by these solar events. Settlement patterns indicate that seasonal labor, such as planting and animal husbandry, was coordinated with solstice observation. Analysis of pollen, phytoliths, and carbonized grains suggests that agricultural activity peaked in ways synchronized with sunlight cycles, implying a direct link between astronomy and survival. In this sense, the winter solstice acted as a calibration point, both guiding practical life and embedding cosmic order into daily routines. The cultural significance extended beyond agriculture and ritual. Iconography carved into the curbstones, spirals, lozenges, and concentric patterns may encode cosmological understanding. Scholars like Yogan and Harbison argue that these carvings are more than artistic expression. They reflect a symbolic language of cycles, motion, and continuity. The solstice illumination animates these symbols, perhaps serving as a didactic tool, reinforcing cosmological knowledge across generations. In effect, light becomes a teacher, transmitting both practical and philosophical insight. Evidence from isotopic analysis of human remains indicates that communities around Newgrange were mobile, engaging in trade and exchange over significant distances. This mobility may have facilitated the spread of solstice knowledge and techniques, creating networks of shared astronomical understanding across Neolithic Ireland and beyond. The solstice, therefore, was not just a local phenomenon. It acted as a temporal and cultural anchor, connecting dispersed groups within a coherent framework of observation, ritual, and social organization. The winter solstice also appears to have structured social hierarchy and responsibility. The effort to maintain precise observation, to construct the passage with millimeter-level accuracy, and to coordinate large-scale feasts suggests specialized roles within the community. O'Kelly and more recent anthropological interpretations by Timothy Darvill argue that this implies an institutionalized form of astronomical knowledge, where certain individuals carried expertise critical to survival, ritual, and cosmological understanding. The solstice was thus a measure of both time and societal order, and yet, as we peer into Newgrange, one question arises. Why would unrelated societies across the world, spanning the deserts of Peru, the high Andes, and the plains of Africa, arrive at similar solutions, encoding solstice events with comparable precision? Could it be that the winter solstice functioned as a universal calibration point, a cosmic benchmark that humans intuitively recognized as essential for both practical survival and spiritual alignment? The notion is tantalizing. Independent civilizations, separated by oceans and continents, observing the same celestial rhythm, creating monuments that intersect observation, ritual, and social cohesion. The evidence hints at a profound cultural principle. The solstice is more than an astronomical event. It is a cultural compass. For the Neolithic people of Ireland, life and cosmos were inseparable. Every gathering, every ritual, and every act of construction reflected an understanding that human existence is bound to celestial cycles. In observing the sun's return, these communities measured not only time but the order of the universe, embedding this knowledge in stone, in landscape, and in practice. And as the first rays of the winter solstice illuminate the chamber, one cannot help but wonder. If the sun could communicate such order and structure in Ireland, what secrets might it have revealed to the architects of Machu Picchu, Chanquillo, or Giza? How far did human observation stretch to encode the cosmos across landscapes so vast, cultures so distant? The answer begins to emerge in the architecture, in the ritual, and in the lives of those who turn to the heavens with reverence and calculation. In Mesoamerica, the Maya provide a compelling answer. Their pyramids, plazas, and observatories were designed not only to dominate the landscape, but to synchronize society with the movements of the heavens. Structures such as the Pyramid of Kukulkan at Chichen Itza are aligned so that, during the equinoxes and solstices, sunlight and shadow produce the illusion of a serpent descending the staircase, a precise demonstration of astronomical observation embedded in monumental architecture. This phenomenon, studied extensively by researchers including Anthony Aveni and Ivan Spreich, reflects not casual coincidence, but deliberate calibration to solar cycles, mirroring similar principles observed at Newgrange, Chanquillo, and Machu Picchu.
The Maya did not observe the sun in isolation. Civic planning, ritual, and agriculture were intertwined with astronomical precision. The orientation of entire cities often corresponded to solstice or zenith passage events, suggesting that urban space itself acted as a functional calendar. Excavations and epigraphic studies indicate that ceremonial plazas and ball courts were aligned with the rising and setting sun on key calendar dates, which guided both religious observances and civic gatherings. Aveni notes that the Maya combined solar observation with a complex calendrical system, including the Tzolk'in and Hab, allowing them to track both ritual cycles and agricultural seasons with remarkable accuracy.
Life in these cities was organized around these celestial rhythms. Seasonal festivals coinciding with solstice or zenith sun events drew thousands of participants. Archaeological evidence from sacrificial altars, offerings, and cenotes, natural wells considered sacred, shows that ritual observance was timed to align with solar phenomena. The interplay of architecture, sunlight, and shadow served as a communal cue, orchestrating feasts, market activity, and religious ceremonies in a coordinated social rhythm. The solstice was not only observed, it structured civic life, labor, and belief. Mayan astronomers and priests, as indicated by codices and stelae, were central to this process. They maintained records, observed solar motion, and predicted solstitial events, guiding both rulers and the populace. The Dresden Codex, for instance, contains tables that track Venus and the Sun, which allowed predictions of solar extremes with impressive precision. Scholars like Anthony Aveni argue that these observations were institutionalized, passed down through generations, and integrated into governance. The solstice became a calibration point that linked temporal, social, and political structures, echoing the principles evident in Ireland, Peru, and Egypt. The precision achieved in Mesoamerica parallels that of Old World sites, despite radically different tools and environments. Measurements of pyramid alignments show deviations of less than 1 degree from the solstice sunrise or sunset azimuths. These results, verified by Spreich and others using modern surveying equipment and satellite imagery, suggest deliberate calculation and observation. Similar to the roof box at Newgrange or the Chanquillo Towers, Maya architects and astronomers translated the movement of the sun into permanent, measurable forms, embedding temporal knowledge into stone. Agriculture, too, was tied directly to solstitial observation. The Maya relied on maize cultivation, which required precise timing of planting and harvesting to avoid drought or flood. The solstice, marking the extremes of the sun's path, provided a natural anchor. Pollen analysis and soil studies near ceremonial centers indicate cycles of planting that align closely with these solar events. By encoding the sun's motion in both architecture and ritual, the Maya ensured that agricultural knowledge was reinforced through observation, ceremony, and communal memory, a combination of practical necessity and symbolic meaning. But the solstice's influence extended beyond the material and practical. Ritual precision and symbolism permeated Mesoamerican cosmology. Light interacting with pyramids, plazas, and carvings was perceived as divine communication. Sun gods such as Kinichahau were central to belief, with ceremonies marking solstice moments acting as a dialogue between humans and the divine. The alignment of pyramids with sunrise or sunset reinforced social hierarchies, with rulers and priests mediating between celestial order and human society. As Avani emphasizes, these practices were simultaneously scientific, religious, and political. The solstice was a unifying principle, linking observation, belief, and governance. Interestingly, some Mayan centers, like Uxmal, combine solstitial alignment with lunar and Venus cycles, reflecting an integrated cosmology. Here the sun was the anchor point, the reference against which other celestial movements were calibrated. This mirrors the hypothesis proposed by Giulio Magli regarding Giza, that certain monuments were not isolated but part of a system encoding temporal, astronomical, and possibly energetic principles. Across continents, societies recognized that anchoring knowledge to the sun offered a universal reference, a calibration point that structured both practical life and spiritual order. The solstice also served as a medium for education and memory. Ceremonial architecture functioned as a teaching tool. By observing the play of light on staircases, altars, and plazas, novices learned about the solar year, agricultural timing, and ritual propriety. Epigraphic studies, including the codices and stelae, show glyphs associated with solstice events, solar cycles, and ritual calendars. This indicates a deliberate transmission of knowledge across generations, embedding astronomy into cultural literacy, social cohesion, and governance. And yet, one cannot help but wonder, if the Maya, separated by thousands of kilometers and centuries from the builders of Newgrange, Stonehenge, or Chankillo, arrived at comparable solutions, what fundamental human impulse drives this convergence? Is it necessity, observation, or an innate recognition of the sun as the ultimate measure of time and order? The answer may lie not only in survival or ritual, but in a universal human inclination to align life with cosmic cycles, a principle inscribed in stone from Ireland to Mesoamerica. By observing the sun, the Maya created a system that was simultaneously practical, ceremonial, and philosophical. Solstice events calibrated social life, agriculture, and religion. Monuments recorded and transmitted knowledge, and ritual illuminated cosmic order for the community. These achievements underscore a broader pattern. Across continents and cultures, humans independently recognized the solstice as a natural benchmark around which civilization could be organized. As the sun rises along the horizon of Chichen Itza, casting the shadow serpent down the steps of the pyramid, we are reminded that the same celestial principle guided builders in Ireland, Peru, and Egypt. And the question remains, if the solstice could shape life and society so profoundly across disparate cultures, what other hidden patterns might the sun encode, waiting to be decoded by our modern eyes? In the high deserts of Peru, the Chankillo complex provides a remarkable answer. Constructed over 2,300 years ago, the site features 13 towers stretching along a ridge, forming a solar observatory unlike anything else in the Americas. Researchers, including Ivan Gezi and Clive Ruggles, have shown that each tower marks the position of the rising sun throughout the year, offering a precision calendar for agricultural and ritual purposes. As the sun slides along the horizon, its alignment with the towers signals planting seasons, ceremonial dates, and social coordination. Here, the sun is both teacher and arbiter, anchoring human activity to celestial rhythm. Archaeological surveys reveal that Chankillo was not an isolated observatory, but part of a complex socio-economic system. Terraced fields, reservoirs, and residential areas are aligned with solar markers, suggesting that agricultural labor was scheduled according to solar events. Pollen analysis and isotopic studies indicate that crops like maize, beans, and quinoa were planted and harvested in harmony with solstice observations. Seasonal water management relied on this precise knowledge, allowing communities to conserve and allocate scarce resources in the arid coastal valleys. The solstice, in effect, became the pulse of the landscape, governing not only ritual but survival itself. The cultural and ritual dimensions of Chankillo are equally striking. Excavations led by Gezi have uncovered ceremonial structures near the towers, including altars and offerings, which indicate that solstice observation was intertwined with religious practice. The alignment of the towers with sunrise and sunset created an orchestrated spectacle, likely observed by priest astronomers and elites who interpreted these celestial events for the broader population. Such observations reinforced social hierarchy, legitimized leadership, and ensured that cosmic order mirrored terrestrial governance. In this way, Chanquillo served as both calendar and sacred stage, bridging astronomy and society in a tangible, observable way. Further south, the Inca civilization carried this principle to extraordinary heights at Machu Picchu. The Intihuatana stone, often referred to as the hitching post of the sun, demonstrates precise astronomical understanding. Studies by Johann Reinhard and Brian Bauer indicate that during solstice moments, the stone casts shadows in a way that marks the turning points of the sun's annual path. This guided agricultural cycles on Machu Picchu's terraces, influencing when crops were sown and harvested across microclimates that range from steep valleys to high ridges. Once again, celestial observation is inseparable from the practical necessities of life, linking survival to cosmic order. Machu Picchu's urban design itself embodies solar knowledge. Streets, plazas and temples align with solstitial sunrise and sunset, creating deliberate sightlines for observation. Chroniclers like Pedro Sarmiento de Gamboa described Inca rulers performing rituals at these precise moments, blending religious authority with calendrical function. The solstice illuminated more than stone. It illuminated hierarchy, culture, and societal cohesion. Here, the celestial and terrestrial were inseparable, each reflecting the other in a carefully orchestrated dance of light, labor, and ritual. The cultural implications extend beyond architecture. Analysis of artifacts, ceremonial pottery, offerings, and textiles indicates that solstice ceremonies involved the wider community. Feasts, processions, and ritualized labor marked these events, reinforcing shared cosmology and collective memory. The solstice was a teacher, a regulator, and a symbol. It encoded temporal order, social structure, and spiritual significance into daily life. In these societies, knowledge of the sun was knowledge of life itself, encoded in stone, ritual, and social practice. Precision at Chanquillo and Machu Picchu reflects advanced observation techniques. Surveys of solar angles, horizon profiles, and sightlines demonstrate that deviations from exact solstice alignment rarely exceed 1 degree, a remarkable achievement given the lack of mechanical instruments. Researchers like Reinhard argue that repeated observations over decades, likely by a class of priest astronomers, produced this accuracy. This implies not only sophisticated empirical methodology, but a cultural imperative. The sun's motion was too important to leave to chance. Human life, ritual, and agriculture all depended upon it. Philosophically, these Andean societies reinforce a broader pattern visible across the globe. From Newgrange to Chanquillo, humans recognized the solstice as more than a marker of seasonal change. It was a universal calibration point, a reference that structured not only work and ritual, but societal hierarchy, architecture, and memory. Ivan Gezi emphasizes that the convergence of solstice alignment across continents points to a shared human cognition, an instinctive recognition of celestial order and its potential to organize life. The sun, it seems, was a constant teacher, guiding independent societies towards similar solutions to the challenges of time, survival, and meaning. And yet the story deepens. The towers of Chanquillo, the terraces of Machu Picchu, the Intihuatana stone, all encode patterns that are visible only when time and light intersect in specific ways. This raises a haunting question. If the solstice guided societies across continents, what other hidden patterns might the ancients have encoded in stone, visible only to those who knew where, when, and how to look? The sun, it seems, is revealing a global design, a language of light that transcends geography and era. The Andean example teaches us that astronomical observation, cultural practice, and social organization were inseparable. Precision in architecture reflected precision in society. Ceremonial and agricultural practices were synchronized with solar movement. Ritual reinforced hierarchy, memory, and shared identity. In the Andes, as in Ireland, Mesoamerica, and Egypt, the solstice served as a universal anchor, a calibration point linking the cosmos, human society, and the rhythms of life itself. As the sun ascends along the Andean ridge at Chanquillo, or casts its shadow across Intihuatana, we begin to see a pattern emerging. A global template of solar observation, ritual, and social integration. And it is here, at this intersection of culture, architecture, and astronomy, that the question arises: could the solstice have been used not just to measure time, but to map energy, encode knowledge, or even harmonize human activity with natural forces in ways we are only beginning to understand? If the solstice guided societies across continents from Ireland to the Andes, then nowhere is its imprint more monumental than on the Giza Plateau. Here, the alignment of pyramids, causeways, and temples demonstrates a civilization whose understanding of celestial motion was inseparable from its political, spiritual, and practical life. The Great Pyramid of Khufu, oriented to true north within a fraction of a degree, anchors a complex network of causeways and temples that interact with sunlight at solstitial extremes. Scholars such as Giulio Magli and Kate Spence have studied these alignments in depth, revealing a society that encoded astronomical knowledge into its landscape with astonishing precision. Archaeological surveys show that the main axis of Khufu's pyramid is aligned almost perfectly to the cardinal points, with only a 3 arc-minute deviation from true north, an accuracy that continues to awe modern engineers. The pyramid's orientation is not isolated. The causeways connecting the pyramid to valley temples and satellite pyramids follow paths that interact with sunlight and shadow during solstice moments. Spence proposes that the builders used a combination of stellar observation, particularly of circumpolar stars, and careful surveying techniques to achieve this precision, creating a permanent celestial benchmark on Earth. Egyptian culture was deeply structured around the sun. The deity Ra, emblematic of life, order, and time, was central to religious practice, and solar observation informed both ritual and governance. At Giza, temples along the causeways were positioned so that during solstices, sunlight would illuminate specific statues, sanctuaries, and ceremonial spaces, marking the passage of time and reaffirming cosmic order. Rituals performed in these spaces, often involving the pharaoh or high priests, were timed to coincide with these solar alignments, ensuring that political authority and cosmic order were symbolically synchronized. The integration of solstice observation into daily and ceremonial life is evident in tombs, inscriptions, and temple layouts. Excavations of nearby worker settlements reveal that labor on pyramids and temples was often scheduled seasonally, corresponding to the Nile's flood cycles and solstitial events. Analyses of agricultural deposits, including barley and emmer wheat, suggest that timing planting and harvesting with celestial events was a practical necessity, directly tying cosmic observation to survival. The solstice was a marker, a calendar, and a guide for societal activity. Further evidence of cultural significance comes from the Great Sphinx and its orientation. Some researchers propose that the Sphinx, facing east toward the rising sun, aligns with sunrise on the vernal equinox, while the surrounding temples interact with solstice sunrises and sunsets. This implies that the Giza complex functioned as a holistic solar instrument, monuments, causeways, and temples interacting with sunlight to create predictable patterns visible across the plateau. Light, shadow, and stone combine to encode knowledge, ritual, and power simultaneously. Magli's studies on the Giza Plateau suggest that the pyramid's positioning was also connected to stellar alignments, particularly the circumpolar imperishable stars, reflecting the Egyptian belief in the eternal. The combination of solar and stellar orientation hints at a sophisticated cosmology. The solstice may have acted as a calibration point for both terrestrial activity and metaphysical order. By encoding celestial cycles into monumental architecture, the Egyptians created a permanent record of time, rhythm, and cosmic hierarchy. The labor force, often idealized in popular imagination, reflects broader cultural integration of solstice knowledge. Worker villages and quarries reveal evidence of organization, social hierarchy, and ceremonial life. Funerary practices, feasts, and offerings suggest that participation in construction was more than physical labor. It was a ritualized engagement with cosmic cycles. By moving massive stones, aligning them with celestial events, and maintaining observatories, these workers contributed to the encoding of solstice knowledge into the landscape, linking ordinary life with cosmic order. Archaeological and archaeoastronomical research provides further precision. Using satellite mapping, horizon profiling, and ray tracing simulations, scholars have demonstrated that the Giza Pyramid's alignment is optimized for solar observation across the year. During the winter solstice, light interacts with the sides of the pyramids and causeways in patterns that may have been used to time ceremonial or agricultural activities. The combination of architecture, landscape, and astronomy reflects a deliberate cultural choice. The sun was the ultimate arbiter of time, ritual, and societal structure. Egyptian texts, including the pyramid texts and later inscriptions, reinforce the cultural significance of solar alignment. These writings emphasize the pharaoh's role as intermediary between the sun, god Ra, and the people, linking governance, ritual, and cosmic cycles. Solstice observances reaffirmed this order, synchronizing political authority with celestial phenomena. Scholars such as Mark Lehner emphasize that these patterns were not decorative but functional. The alignment of pyramids, causeways, and temples created a framework for measuring time, structuring ritual, and reinforcing social hierarchy. Philosophically, the Giza Plateau illustrates a profound principle. The solstice serves as a universal calibration point, enabling independent civilizations to synchronize life, ritual, and architecture with the cosmos. The Egyptian example shows that precise observation, monumental architecture, and societal integration were not isolated practices, but part of a global pattern repeated across continents, from Ireland to Mesoamerica to the Andes. The sun, in effect, provides a common metric, a natural standard against which societies could measure both time and meaning. And yet, the mystery deepens. If the Egyptians, Maya, Andean, and European societies all encoded the solstice with comparable precision, could there be a broader, perhaps even universal language in these alignments? A code hidden in stone and shadow, linking human activity with solar and stellar cycles. The patterns at Giza hint at a system that transcends geography, suggesting that the solstice may have been used not only to measure time, but to encode knowledge, align energy, and harmonize human life with the cosmos. As the winter solstice sun rises along the causeways, illuminating temples and pyramids in exacting sequences, one sees the same principle repeated worldwide. Humans instinctively calibrating their existence to a celestial rhythm, creating monuments that are simultaneously practical, ritualistic, and symbolic. The sun is not merely observed, it is measured, encoded, and revered. And as we begin to trace these patterns across deserts, mountains, and valleys, a startling question emerges. What other messages might these monuments hold, waiting for a mind capable of reading the language of light and stone? In the harsh, arid expanse of Egypt's Nubian desert, long before the grandeur of Giza, humans were already observing, calculating, and honoring the sun. Nabta Playa, a prehistoric ceremonial center dating back to around 5000 BCE, presents one of the earliest known examples of monumental solar alignment in Africa. Here, stone circles, megalithic alignments, and buried artifacts reveal a society that understood the sun's rhythm as a guiding principle for both life and ritual. Researchers such as Thomas G. Brophy and Fred Wendorf have documented the site's astronomical precision, showing that certain stone arrangements align with the summer solstice sunrise, marking the extreme point of the sun's path on the horizon. What is remarkable about Nabta Playa is not only its age, but its sophistication. Unlike later pyramids or Andean observatories, these stones were arranged with limited technological resources, yet they achieve alignment accuracy within a few degrees of the solstice horizon. Using satellite mapping and ground surveys, Wendorf and colleagues demonstrated that the so-called calendar circle functioned as a solar observatory, allowing inhabitants to predict seasonal changes crucial for survival. The solstice was a natural signal for the onset of the rainy season, guiding agricultural planning, water management, and communal gatherings. Life in this early desert society was intimately tied to these celestial events. Archaeological evidence indicates that Nabta Playa's inhabitants were pastoralists, raising cattle, goats, and sheep. Seasonal migrations were carefully timed, and alignment with the solstice likely helped coordinate movement and grazing patterns across the desert's scarce resources. This synchronization of human activity with solar cycles reflects a broader principle visible across ancient civilizations. The sun served as a calibration point, a universal reference anchoring both ritual and survival. Ritual practices at Nabta Playa were sophisticated and symbolic. Excavations uncovered elaborate stone circles, some containing carved megaliths resembling animals or celestial motifs. These may have represented constellations, solar cycles, or mythological figures, suggesting that the observation of the sun was intertwined with spiritual life. Anthropologists argue that ceremonies performed at the solstice reinforced social cohesion, transmitting knowledge about time, cosmology, and seasonal cycles to successive generations. In this sense, the solstice functioned as both a practical guide and a medium for cultural memory. The accuracy of Nabta Playa's alignments is especially striking when considered in context. Studies using 3D simulations and ray tracing models indicate that during the summer solstice, sunlight passes precisely through key openings or gaps in the stone arrangements, illuminating central markers or shrines. This phenomenon implies deliberate observation over years, careful planning, and a class of individuals, ritual specialists or astronomer priests, tasked with maintaining this celestial knowledge. Such specialization echoes patterns seen in New Grange, Chanquillo, and Giza, revealing a universal human impulse to anchor life to the movement of the sun. Cultural life around Nabta Playa was also shaped by environmental challenges. Water scarcity, extreme heat, and seasonal variability demanded precise timing for migration, grazing, and settlement. The solstice offered a reliable celestial signal, allowing communities to organize themselves and coordinate labor-intensive activities, such as constructing ceremonial stone circles or preparing for ritual feasts. Archaeological analysis of pottery fragments, burial sites, and animal remains indicates that ceremonial and practical life were tightly interwoven, reinforcing the idea that solstice observation was both sacred and utilitarian. Interestingly, the desert culture of Nabta Playa demonstrates a continuity of solar reverence that would echo into the Pharaonic period. The alignment of early ceremonial stones parallels later temple and pyramid orientations along the Nile. Scholars such as Magli and Wendorf suggest that Nabta Playa represents an ancestral template for solar architecture, establishing principles that would later be elaborated in Giza's pyramids and temples. The solstice observed in these early circles becomes a recurring motif, a natural constant around which human knowledge, ritual, and architecture are calibrated. This society also demonstrates the integration of astronomy, ritual, and social structure. The size and scale of the stone circles imply organized labor, communal planning, and hierarchical coordination. Seasonal ceremonies likely drew participants from surrounding regions, reinforcing alliances and transmitting cultural knowledge. The solstice was thus a focal point, around which social, spiritual, and practical life converged, highlighting a fundamental principle. Human societies, even in extreme environments,
recognize the sun as both a guide and a teacher.
Yet a philosophical question emerges. If communities in deserts, mountains, river valleys, and temperate Europe all independently encoded solstice knowledge into monuments, rituals, and calendars, what does this say about the human mind? Does it suggest an innate drive to understand and harmonize with cosmic rhythms, or is it simply a practical response to the necessities of agriculture and survival? Perhaps it is both. Nabta Playa teaches us that celestial observation can simultaneously serve practical, ritual, and philosophical functions, a principle that resonates across continents and eras. As the first light of the summer solstice illuminates the stone circles, we glimpse a global pattern. The same sun that casts shadows across Nabta Playa also shines on Newgrange, Chanquillo, Machu Picchu, and Giza. Across millennia and geography, humans have consistently recognized its rhythm, encoding it in stone, ritual, and social practice. And yet, the desert stones hint at something more profound. If the solstice served as a calibration point for life, work, and ritual, could these early societies also have perceived patterns, cycles, or energies invisible to us today, encoded in light, shadow, and stone? The answer lies in the interplay between human observation and celestial motion, a dialogue written across landscapes, awaiting rediscovery. Across continents and millennia, the solstice appears again and again, inscribed in stone with uncanny regularity. Scholars and statisticians have attempted to quantify this phenomenon, asking whether these alignments are mere coincidence, the result of shared human intuition, or evidence of a deeper, perhaps lost, methodology. Anthony Aveney, in his comprehensive surveys of archaeoastronomical sites, has noted that the odds of sites like Chanquillo, Newgrange, Stonehenge, Machu Picchu, and the Mayan pyramids aligning within a single degree of the solar extremes by chance are vanishingly small. When hundreds of structures across cultures that never exchanged contact all converge on the same solar events, the probability of randomness collapses under scrutiny. Recent studies have applied statistical models to evaluate this convergence. Researchers measure the azimuths of key solar markers, the orientation of pyramids, temples, or ceremonial avenues, and calculate their deviation from true solstitial sunrise or sunset. In some cases, the margin of error is less than 1 degree, an astonishing feat considering the prehistoric tools available. When these measurements are aggregated across dozens of sites worldwide, the pattern is no longer anecdotal. It becomes a statistically significant global signal. Satellite imaging and remote sensing now allow for unprecedented precision. With LiDAR and GIS mapping, archaeologists have confirmed long-distance alignment patterns previously invisible to ground surveys, revealing networks of solar attunement spanning thousands of kilometers and disparate cultures. Yet the question remains, what drove this convergence? One hypothesis is convergent evolution of human cognition. Across isolated societies, humans independently recognized the sun's cyclical extremes as a natural anchor for time, agriculture, and ritual. In essence, the sun provided a universal solution to the same problems, measuring seasons, regulating food production, and structuring ceremonial life. This theory suggests that independent societies arrived at similar architectural solutions not through direct contact, but through shared environmental pressures and cognitive universals. The careful placement of stones, the construction of towers, the design of roof boxes and plazas all reflect a human instinct to impose order on the cosmos. The alternative hypothesis posits the tantalizing possibility of shared knowledge, that ancient civilizations, perhaps through migration, trade, or lost lines of communication, transmitted fundamental principles of solar observation. While direct evidence for such global exchange is sparse, the consistency of architectural solutions challenges our understanding of prehistoric ingenuity. Could there have existed a common conceptual framework, a proto-scientific language of the sun, encoded in the monuments themselves? Or is it more plausible that the human mind, faced with the same cosmic cycle, independently generated remarkably similar solutions? Satellite and remote sensing analyses have begun to reveal correlations that defy simple explanation. In some regions, the azimuths of ancient structures correspond not only to solstitial sunrises and sunsets, but also to alignments with distant sites, suggesting a larger, possibly intentional spatial logic. For instance, the line connecting Nabta Playa's stone circles with other Saharan ceremonial centers corresponds approximately to solstitial axes observed thousands of kilometers to the east in Egypt. Similarly, the axes of Newgrange and other European Neolithic monuments show alignment patterns that, when plotted, hint at geometric relationships echoing across landscapes. These correlations suggest that prehistoric builders were not only observing the sun, they were situating their constructions within an extraordinary awareness of geography, horizon, and celestial motion. From a philosophical perspective, this convergence speaks to the universality of human cognition. The solstice, far from being a trivial astronomical event, became a shared reference point across disparate societies. Its significance transcended geography, language, and material culture, reflecting an innate human drive to measure, understand, and harmonize with the cosmos. The alignment of stones, towers, and pyramids is, in a sense, a manifestation of a collective intelligence, a dialogue between humanity and the sun. Every shadow cast, every beam of light penetrating a chamber at the exact moment of solstice, is a testament to the same fundamental curiosity, the same compulsion to anchor human life within the rhythms of the universe. Statistical analyses suggest that the probability of all these civilizations independently achieving such precision is exceedingly low. The consistency across cultures, from the deserts of Peru to the plains of Ireland, from the forests of Mesoamerica to the African savanna, points to either extraordinary coincidence or a deep universal principle guiding human thought and architecture. Satellite data confirms that these patterns are neither isolated nor sporadic. They form a network of solar attunement that spans the globe, suggesting that ancient humans, despite isolation and technological limitations, were capable of systematic observation, calculation, and planning on a scale previously thought impossible. As we consider these patterns, probabilities, and possibilities, we are forced to confront a humbling question. Are we witnessing the echoes of independent genius repeated across time and space, or are we glimpsing the first threads of a global code, encoded by humans who understood, in ways we are only beginning to comprehend, the fundamental rhythm of the sun? Each alignment, each shadow, each sunlit tower becomes a point of contact between civilizations separated by oceans and millennia. The solstice, once merely the shortest day of the year, emerges as a symbol of continuity, connection, and cosmic awareness, a unifying thread in the tapestry of human history. And so we are left with a tantalizing possibility. What if these solar calibrations are more than practical tools? What if they are a silent, enduring language, a code that links humanity across continents, cultures, and centuries? The sun rises and falls as it always has, yet through these alignments, it may be whispering the first words of a message that stretches across the world, from one civilization to the next, waiting for us to listen, interpret, and understand. For thousands of years, the sun has risen and set over deserts, plains, jungles, and mountains, indifferent to the lives it illuminates. Yet across those same millennia, humanity has paused, observed, and encoded its journey into stone and shadow. From the roof box of Newgrange to the 13 towers of Chanquillo, from Machu Picchu's Intihuatana to the pyramids of Giza, civilizations separated by oceans and epochs looked to the same sun, tracking its passage with astonishing precision. They built monuments that spoke not only of power or ritual, but of a profound understanding, a recognition that the sun's motion was a clock, a guide, a cosmic rhythm to which human life itself was tethered. We are left to marvel not merely at the engineering feats, the towering stones,
or the meticulously aligned plazas. We are confronted with a deeper truth. These monuments are monuments to cognition itself, testaments to a universal human impulse to measure time, to understand cycles, to harmonize existence with the cosmos. Statistical analysis, satellite mapping, and archaeoastronomical studies reveal patterns that are neither isolated nor accidental. The solstice was more than a day. It was a thread connecting disparate societies, a shared reference point embedded in the Earth's geometry and the human imagination.
Yet as we trace these threads, a tantalizing question emerges. Were these civilizations, isolated as they were, independently drawn to the same solutions by sheer necessity and observation? Or were they participating in a larger global dialogue, a network of knowledge, ritual, and cosmic awareness now lost to history? Perhaps the sun itself, in its unwavering course, offered a language that humans everywhere could understand, a silent instruction manual for organizing life, agriculture, ceremony, and the very architecture of belief. Consider the rituals, the festivals, the careful tracking of shadows and light. The Maya watching their pyramids transform under the solstice sun. The Incas aligning plazas and stones to mark planting and harvest. The priests of Egypt orchestrating ceremonies along Giza's causeways. The people of Neolithic Europe gathering at Stonehenge as the midwinter sun strikes its heart. Each of these moments is a dialogue between humanity and the cosmos, a testament to the awe, curiosity, and ingenuity that define our species. The solstice was a shared rhythm, a cosmic metronome marking the passage of time and the order of life. And yet, despite all we know, mysteries remain. How did these people with no telescopes, no satellites, no modern instruments achieve such precision? How did they encode astronomical cycles into ritual urban planning and monumental architecture? Could there have been principles now forgotten that guided their hands and eyes? Each shadow and sunbeam offers a hint, a whisper from the past, suggesting a language of light and stone that humanity once shared across continents. We are drawn inevitably to reflection. Perhaps the solstice was humanity's first attempt to reach beyond the immediate, to measure our fleeting lives against the timeless universe. Perhaps it was instinct or intuition or a nascent science born of wonder, or perhaps somewhere in the alignment of these monuments, in the shadows they cast and the sunbeams they welcome, lies a fragment of lost knowledge, a global code that tied together the thoughts and rituals of the distant past. In the end, the sun whispers still. Every winter solstice, every summer sunrise, every equinox shadow offers a subtle reminder that across the vast distances of time and space, humanity has sought connection, not just with each other, but with the cosmos itself. The stones, towers, and temples are more than relics. They are echoes of a universal conversation, a dialogue that began before recorded history and continues quietly today, in the rising light of each solstice morning. As we watch the sun crest the horizon, casting golden light over monuments both ancient and distant, we are invited to listen, to interpret, and to marvel. The same cosmic rhythm that guided the Maya, the Egyptians, the Andeans, and the peoples of Europe still pulses above us. It reminds us that though civilizations may rise and fall, the sun's journey is eternal, and so too is humanity's desire to understand, measure, and harmonize with the universe. The solstice is not merely a celestial event, it is a bridge across millennia, a thread linking civilizations, a testament to our shared fascination with time, light, and the cosmos. Perhaps in these alignments and shadows, in the careful tracking of the sun across deserts, mountains, and plains, we glimpse something profound, a humanity united in wonder, curiosity, and awe. The sun rises, and in that light the past speaks. Are we listening closely enough to hear what it has to tell? Thank you for joining us on this extraordinary journey through the universe on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, Be sure to subscribe and join us, where we unravel the darkest mysteries of space.